Hi, in this video we are going to discuss about data structures. So what is data structure? So initially what is data? Data is nothing but the information I need to do some process. It may be anything. It may be a name or age or date of birth or the location, right? Whatever it is, right? So set of information I need to process, right? That is what a data is. So what is data structures? See, if I want to have a collection of data to do some process, I need to store the data in a memory for my further process. So all we know, if I write a program, so for a program I need a data for the processing. The data I need to store in a memory, right? So data can be of any type. So it may, there are different data types, that is completely different from this. So we know there are different data types like integer, float, boolean, right? So we have so many data structures, right? So many data types. So if I write a program, right? So I need some data for the processing. So I need to store the data in a memory. And how I am going to store the data in the memory, so that is where these data types comes into the picture. So what is data structure? So as I told, if I want to store the data into the memory, I need to store and sometime I need to retrieve the data. So storing the data and retrieving the data takes some time. For different applications, the type of retrieval, right, the style of retrieving the data from the memory is also different. So using the data structure, I can store the data in the memory in a particular structure in such a way that it is easy for me to retrieve for the process. So whatever the data I need or whatever the format in which I need the data, I can decide the structure in which I can store the data in the memory so that it will make the process easy for me to retrieve the data from the memory to do my processing. So that is where the data structure comes into picture. See, for example, I have a list of inputs to be stored. Just a list of inputs. First one, A, maybe A, C, D. So some data. So there is no other extra structure I require. I just want this to be a list of inputs. So I can store the data as a list into the memory so that I can retrieve one after another to do the process, right? So this is one kind of requirement. Sometimes I need the data in which if I store A first and B next and C next, I need to retrieve the one which I stored last. See, I stored A first, then B, then C. But what I should retrieve first is the one which I stored last. So in this case, if I use the list of inputs in the same way, it will not work well for me. So I need a different structure to store this data in such a way that the input which I stored last could be retrieved first. In some cases, the reverse. If I store A first, B next, C next, whatever I stored first should be retrieved first for me. So again, I cannot use any common structure to implement these two requirements. So if the requirements are different, I need to follow a different structure to store my data in the memory, right? See, sometimes I don't have any constraint. I can store the data and I can retake the data as it is. Sometimes I need some constraint like this. The one which I stored last should be retrieved first, or the one which I stored first should be retrieved first. So if I have some constraint in the process of retrieving the data from the memory, then I need a particular data structure to store these data into the memory. So it will help me to retrieve the data as I require, right? So we have the concept called data structure. So using that, I can store the data in a particular structure. It will help me to retrieve the data as it is required by the process. So what are the different data structures we have? So we can classify basically the data structure as linear and non-linear. Right? So in the linear data structure, we have list, stack and queue. In non-linear data structures, we have tree and graph. I think you can understand the difference in each data structures. I will tell you the differences in each data structures, because each data structure is framed according to the requirement of retrieving the data for the process, right? So starts with a list. So as I said, if there is no constraint, I'm just going to have the sequence of input to be stored in the program and I'm going to retrieve it. I can go with this list. What is stack? This is called last in first out, which means the input which I stored last should be retrieved first. So there are so many applications in which we required this type, LIFO style. And what is queue? Queue is FIFO, first in first out. The data which I stored first should be retrieved first. So again it has its own applications. General queue also take the same application. So if I want to buy a ticket, for example, if the ticket counter has the queue to be followed, then the person who comes first should be serviced first. So in that case the FIFO is required. In the case of LIFO, the one which I stored last should be retrieved first. So for this also we have so many applications. So for that case I need to store all the incoming data in the structure called the stack. And what is this non-linear? Tree and graph. If suppose is there any relationship exists among the data I'm gathering, right? So I can go with this tree or graph. If the data has hierarchical relationship, I can go with tree, right? Because I start with the root, then the children of the root, then the children of those children, selected some hierarchical relationship. If I take a graph, right? See, if I have a node and the node should be the predecessor of the other node or successor of the other node. So in that way, if I have any relationship among my data, I can go with the graph, right? So if there is some relationship exists among the data, I am going to store it, maybe any kind of relationship. So accordingly, I can select the non-linear data structures, right? So we will start with the list. So I told these structures to be followed to retrieve the data easily from the memory when it is required for the process. So how can I represent the data? See, if I am storing a list, for example, right, I can have a list of inputs 1, 2, 3, 4, 5. So how I can represent this? How I can store this? So there are two ways by which I can store, either in the form of array or in the form of linked list into the memory. So you know what is array? Array is nothing but collection of continuous memory location. So if I declare, for example, integer a. So what is the meaning of this? I am going to create a collection of memory whose size is 5 and each memory location, right, can hold an integer. So I can store 5 integers in the continuous memory locations 1, 2, 3, 4, 5, and each unit can hold one integer. So if the integer is of 2 bytes, this holder will have 2 bytes. So this 2 bytes will hold one integer, for example 1. So like that 5 holder will be created, and that too in a continuous manner when I want to create the collection. So this is what an array representation. What is linked list? The linked list, if there are no continuous memory allocations, can be done. If there are no continuous memories are available. For example, I have to have 5 units of memory. Each should hold one integer. For example, if integer is of 2 bytes, right, 10 bytes I need. But there are no 10 bytes free right now in the memory. I cannot create this collection. So what can I do? I can go with the linked list. So in the linked list, what it will do? It will connect all the free memory. See, for example, this part I am dividing. So if it is the case, so these are all occupied memory and these are all free memory. You can see there are no continuous 10 memory locations are available right now, but on the whole more than 10 locations are free, but not in a continuous way. So in that case, I can go with this linked list. So what it will do, it will link all the free memories and it will allow has to store the data, but not in a continuous manner. But there is a link from one location to other location. So here I will be having my data. Here I will be having the address to the next node. So in this case I stored all the 5 data. So this will be considered as one node. So the node will contain the data, minimal informations, data and address of my next node. So this is what linked list representation. So in the linked list, the data will be stored in nodes instead of locations as we discussed in array. Since the case, if there are no continuous required memory or available, I can go with this linked list. So in the linked list, it will link all the free memory such that so continuously I can access one after another even though it is not continuously present in the memory. So each will be considered as a node. So each node will contain one data and a pointer to my next node. So this is how I can store my data into the memory. So it may be of any data structure. I can follow a stack or a queue or the list, whatever it is, tree or the graph. At the end of the thing, I have to store it in the memory either using array or linked list, right? So for example, if I am taking stack, if I am taking the data structure called stack, you know the stack is nothing but lost in first term. So if I am going with an array representation, the stack will grow in this order. So first I have to store my first data in the last. In the top of it I have to store my next data, then next data, then the next data, then next data. It may have some more memory also. So this is the one I stored last, but this is the one I can retrieve first. So this is what the last in first out data structure stack using array. So if this is the case, if I want to represent in the linked list representation, so first I will store my first data. So I will store my first data and the pointer to the second node, right? So in this way I can create it as a nodes and I can store my data, right? So here in this case, so this will be my first data, second data and my third data and my fourth data. So this is the one lastly I added the node. So first there will be a node D1, first node. If I want to add my second one, I have to create one another node. I can store the data and next address of this D2 should be the D1. So first I can access D2, then I can access D1. So in this way I can implement the stack using linked list, right? It is same for your queue. So queue will be the first in first out structure. So the same way I will be storing the data in this order, D1, D2, D3, D4. So the one which arrived first will be the one which I can retrieve first. So these are the very basics informations regarding the data structure. So you should understand first what is data. Data is nothing but the collection of information. We need to do some process. So I need to store it in a memory. How can I store it in a memory? Either in the case with array or linked list, and even to support more to the data processing, we can create a particular structure to store the data, right? So it depends actually upon the requirement of the application. If the application requires LIFO structure, I have to go with the stack. If the application supports FIFO structure, I have to go with the queue. If there is no such constraints, I can go with the list. If I need to represent it hierarchically, I can go with the data structure called tree. See, for example, it will start with the root node, then I can have the children for the root and I can have children for this node. So in this way I can have the hierarchical relationship, I can go with the data structure, right? So these are all the things, right, you should understand initially about what is data structure. Thank you.